Going through the sample assessment material for the new curriculum. So question 1, you have to identify which quantities are scalar and vectors and choose the right row that correctly states whether the quantities are scalar or vectors. So just a reminder that a scalar quantity is a quantity that has only magnitude and units, of course. And the vector quantity is a quantity that has also direction. So on top of magnitude and units, it has also direction. Right, so from this table over here, we know that if we're looking at the scalar, the first column, mass, yes, it is a scalar quantity, it doesn't have any direction. Momentum, if we remember the formula for momentum, is mass times velocity. So since velocity is a vector, therefore momentum is also a vector. So momentum shouldn't be on that column. Speed, it is a scalar quantity, it just has magnitude and units. Velocity, on the other hand, as we just mentioned, is a vector quantity. And weight is a type of force. Therefore, forces are vector quantities. It has a direction which is downwards in that specific case. Now, if we're looking at the vector quantity column, momentum, yes, it is a vector, so it should be on that column. Weight, it is a vector, as we already discussed, so it should be on that column. Mass, nope, doesn't have any direction. Speed doesn't have any direction. Right, so the column that has both correct quantities is the first one, therefore A is the right answer for question 1. For question 2, this has to do with viscosity and temperature. How does viscosity changes with temperature in a liquid, in lava? So it's important to realize that it's talking about a liquid because what's happening in gases is exactly the opposite. So if we look at the graph of how temperature affects the viscosity, this is temperature, this is viscosity. For a liquid, the graph goes like that. So what does this mean? It means that as the temperature increases, the viscosity decreases, or the other way around, as the question is asking us. The question is asking us about lower temperature. So lower temperature will have a higher viscosity. And what is viscosity? By definition, viscosity is the resistance of something to flow. It's how hard something can flow. So something with a higher viscosity, it will be harder to flow, right? So what happens to viscosity when we have lower temperature? Of course, as we just said, it increases. So these two are the possible answers. And if the viscosity increases, what happens to the rate of flow? It decreases. Therefore, D is the right answer. So as I mentioned before, if we look at a similar graph for gases, for a gas, it will be something like that. So in a gas, as the temperature increases, viscosity increases as well. Question 3. A car is traveling at a velocity v, the driver applies the brakes and the car decelerates until it comes to rest. The work done by the brakes on the car is W. Which of the following expressions is correct? Now, there's a few different ways of approaching this question, right? So, as a reminder, what is work? Work is energy, and it can be given by the formula force times distance. So, one way to think about it is that before the car applies the brake, it has some kinetic energy because it's moving, and then when the brakes are applied, it will come to rest. That means all this kinetic energy has been lost. So the work done by the brakes should be equal to the kinetic energy that the car had before you apply the brakes. And we know that the formula for the kinetic energy is half mv squared. So from this equation we can see that the relation of work and V is the one that is described by the second option. Different ways to approach that. If we think that force equals mass times acceleration from the Newton's second law, and then we know acceleration that is a change in velocity over time. So if I substitute that force into that formula over there, what do we get? We get that work equals mass change in velocity over time times distance. And if you see, you will see that distance over time is also velocity. Therefore, it will be work equal mass change in velocity squared. So again, what is the relation between work and velocity? Again, same relation as before. And another approach to that will be that force is the change of momentum over time. And what is momentum? Is mass times velocity, or in that case, because we're talking about change of velocity over time. And again, we do the same thing. We substitute that formula for force into the work formula. Therefore, we have change of velocity over time times d, same as before, d over t, distance over time, that will be velocity. Therefore, we end up in exactly the same thing. So work velocity squared. So three different approaches to this one. So first approach, second approach, third approach. All of them, they give us the same answer. Question 4. A man applies a force F to a box and the box accelerates. The forces acting on the box are shown in the diagram. According to Newton's third law, so we have Newton's third law here, the box will exert a force on the man. Select the row of the table that correctly describes the magnitude and direction of the force of the box on the man. So we're talking about the reaction, let's say, of that force over there that is applied on the box by the man. Just a reminder that this pair of forces, when we're talking about Newton's third law, they need to be of the same magnitude. They have to be acting in opposite directions. They need to be acting on different objects. And they need to be of the same type. And what do I mean by type? They both have to be contact forces or non-contact forces. So now, if F is the action, so the reaction needs to follow these kind of rules, all right? So same magnitude. In that case, we want the magnitude to be the same as the force. Therefore, friction, it's wrong. And then what do we want the direction to be? We want the direction to be opposite to the original force. Therefore, no, it's not going to be at the same direction. It's going to be in the opposite direction, the direction of friction. Therefore, in this case, the correct answer will be F. Will be B. Question 5. So I have added a small diagram here just to explain a few things about laminar flow and turbulent flow. So you see on this question the photograph of air around the wing of an aeroplane. So we can identify the laminar flow, the one I'm highlighting with yellow, and of course the turbulent flow, which is the area I'm highlighting with green. So X and Y are 2 points in the path of the airflow. Which of the following statements about the speed of the air is correct? Now, as a reminder, what do we have on the laminar flow? We have the fluids flowing in layers, and those layers, they don't cross. On the other hand, when we're looking at the turbulent flow, yes, there's no layers anymore because the layers, they cross each other. And also, if you look at a specific point on a laminar flow, velocity stays the same, so velocity is constant. But if you look at a specific point on a turbulent flow, the velocity changes. So now, the possible answers, I can see that answer A says that the speed of the air at x is constant, and yes, we can identify that x is laminar flow, therefore yes, it is constant. So this would be the right answer.